Hi Year 9, welcome to the continuation of the exciting journey into linear relationships. Today we're going to be finding the distance between 2 points, and we're also going to find the point that's in the middle of 2 points. It's called the midpoint. So let's get into it. First of all, let's just consider 2 points. So what I want you to look at here on my diagram is that we've got a point here and a point here. So the first point has an x and a y value, so we'll call that the x value of point 1 and the y value of point 1. So you go out the x value of point 1 and up the y value of point 1, and there is our point. For the second point, you go out an x value called the x value of point 2 and up the y value of point 2. So out to x2, up to y2, and there's our second point. So we've plotted those points. What I want to focus on now is imagine finding halfway between those 2 points vertically. Then imagine finding halfway between them horizontally. That point there is exactly halfway between our 2 points, and it has a special name. It's called the midpoint. There it is, our midpoint. Now, how do you find the midpoint? Well, there's the formula. The midpoint, and notice I'm using a capital M. A little letter m stands for the gradient or the slope. The capital M stands for the midpoint. It's very important you use a capital letter, not a little letter. To find the midpoint, it's the average of the two x values, which finds halfway between them. You add the x value of the first point and the x value of the second point and divide by 2. And then you do the same thing for the y values. Now I want to consider the 2 points again. So there's the point x1 and y1. Now we'll go out x2 and up y2. So there's our second point. Let's join them. Now I want to find the distance between those 2 points. Now in order to find the distance between those 2 points, I'm actually going to use Pythagoras' theorem. So I create a right angle triangle just like we did when we were finding gradient, because there's our rise and there's our run. Let's find this distance. Let's find this distance, and we can use Pythagoras' theorem to find the hypotenuse. So what's this distance and this distance? Well, let's think about this. This is pretty intense. Now, you don't have to memorize this. This is actually proving where a formula comes from, but this is the process. Horizontally, here's an example. Let's pretend I went out 7 to get to there, and this was out, say, 2. So there's 1, 2, 3, 4, 5, 6. How would you find the distance between 2 and 7? Well, what you'd do is you'd say, if we know the full distance is 7, and we know this distance is 2, we could subtract them to find the distance between them. So it'd be 7 minus 2. So let's get rid of all of that now. And think about it like this. Instead of 7 minus 2, it's going to be this x value minus this x value. There it is there. That gives us that distance. Similarly, to find our distance here, it's going to be the full length minus the shorter length vertically. y2 take away y1. Now, if we use our shortcut for Pythagoras' theorem to find this distance here now, we've got a right angle triangle. Remember the formula for Pythagoras' theorem? There it is there. The hypotenuse squared equals a squared plus b squared. So we get d squared equals that distance in bracket squared plus that distance in bracket squared. And we take the square root of both sides. If you remember my shortcut formula, here's our shortcut formula for Pythagoras' theorem. The hypotenuse equals, well, in this case, let's actually just do that again. We're going to use d because the hypotenuse is d. The square root of one of the sides squared. Well, there's one of the sides, so there's that side squared plus the other side squared, and now we also have the same formula. So that's called the distance formula, and you have to know how to use it. The midpoint formula and the distance formula are now listed on the same page. There we go, midpoint formula and the distance formula. And what you need to know is the x value and the y value of one point and the x value and y value of a second point, and you put them into the formulas to find the halfway point, the midpoint, or the distance between the 2 points. Let's try to see it work. Find the distance and the midpoint between 3,5 and minus 6,10. I'm not going to draw the graph. I could do this. Out 3, up 1, 2, 3, 4, 5 and put a dot. Out 6, up 10 and put a dot. Join them, do a triangle, find this length and use Pythagoras to find the distance between them. That would answer that part. I could then find this point and find halfway between by averaging the x values and averaging the y values. That would give me the midpoint. But that's using a diagram and it's messy, especially if the points are awkward. So let's just use our formulas. Well, first of all, this is my first point, so that's the x value of the first point, and this is the y value of the first point. This is my second point. This is the x value of the second point. This is the y value of the second point. So I've labeled each one of these numbers. By the way, if this point was written first and this point was written second and I labeled them differently and this one was x1 and y1, this one was x2 and y2, you'd still end up with the correct answer. The formula takes that into consideration. So don't worry about the order of the points. Just make sure you label them correctly. Both ones, because that's the first point, both twos, because that's the second point. Okay, let's use the distance formula. There's our formula. Now where I see x2, I can put minus 6 in its place. Where I see x1, I put a 3 in its place. Where I see y2, I put 10 in its place. Where I see y1, I put 5 in its place. So I plug those values in. Let's put that straight into my calculator, and it's about 10.3 units to one decimal place between those 2 points. Now, let's try our next one. The midpoint. Well, here's our formula, and if I use this formula, then it's a case of looking at the x1 and y1 and the x2 and y2 values and putting them in. So let's put our values in, same numbers. This is the one that tricks people. When you are using this formula, there's a comma in the formula, and you can't do the x and the y values in one go. That comma is saying separate the two parts. Do the x parts first by themselves. So this is a calculation on your calculator. So just do 3 plus negative 6 over 2. Once you've done that, write your answer down. Then do as a separate calculation 5 plus 10 over 2. Write your answer down. Put a comma between them, put them in brackets, and that gives you your answer. Now whether you write them as improper fractions or mixed fractions or decimals doesn't really matter as long as you get them correctly. And that point there is halfway between 3,5 and negative 6,10. So there it is as a decimal as well. You don't have to write this one here. You can leave it like that. That's fine. Let's try it again. Now this is a bit different. This is, in this question, the coordinates of the midpoint are 7,2. So that's the point that's in the middle. One of the end points we'll call A. That's our point there. And this point, point B, is at the other end. We want to find out what it is. So if I drew a graph, and you don't have to do this, but if I drew a graph, 7,2, out 7, 4, 3, 4, 5, 6, 7, up to there's the midpoint. This point, 1 comma negative 4, 1, 2, 3, 4 is there. If I was to join them, A and B would be somewhere like that because M is the middle point. It's halfway between them. This is the point we're trying to find. That's what we're actually doing. Now, it's possible to draw the picture and figure out how far have you gone across, how far have you gone up, go across the same distance, go up the same distance, and you can then generate that point. But we're going to actually use our formula. So, let's have a look at it. Let's just label everything we know. There's, whoops, let's get rid of that. There is the x value and y value of the one endpoint we know. The other endpoint, because x1 and x2 are the endpoints. The other endpoint, x2 and y2, I don't know, that's what I'm going to be finding. And the middle point has an x and a y value of 7 and 2. Let's use method 1. Now this is the more confusing method. Mathematically speaking, it's the more correct method, but it's more difficult than method 2. Method 2 is quite quick. Method 1, more complicated. Let's see how we go. Here is our formula. Now remember, because our formula has a comma in it, there it is there, we have to do this part separately and this part separately. So, let's put in the information that we know. We know that the midpoint, the halfway point, is the point 7, 2 because it tells us. We know that x1 is 1. We don't know what x2 is, so we just keep calling it x2. And it's over 2 in the formula. y1 plus y2. We know y1 is minus 4. We don't know what y2 is, so there is our statement. Now, when these 2 points, if they are equal, when these 2 points are connected, you look in front of the comma for both points. There's a 7 in front of the comma in the first point, a 1 plus x2 over 2 in front of the comma for the second point. They must be equal. Now, similarly, if I look at the second values, after the comma there's a 2, after the comma there's a negative 4 plus y2 over 2. They must be equal. But before I actually worry about the y values, let's follow this x value part through. I want to get x2 by itself, so let's times both sides by 2. I'll cancel, so it'll be left 7 times 2. I'll get 14 equals 1 plus x2 minus 1 to both sides, and I get x2 equals 13. Now, as I said, after the comma there's a 2, after the comma there's a negative 4 plus y2 over 2, so they must be equal. Well, let's get y2 by itself by timesing both sides by 2. So you get 2 times 2 here, which is 4, equals negative 4 plus y2. Now you're going to plus 4 to both sides, and that'll give you y2 equals 8, which means point B is the point 13, because that's the x value of point B, comma 8, because that's the y value of point B. And there's our solution. This is a trickier question. Normally, you know the 2 endpoints and you've got to find the middle point. This is where you know the middle point and one endpoint and you're finding the other endpoint. So it's a bit trickier. Now, method 2 I think is easier, and it's just draw a sketch. I just draw a horizontal line. And then I put what I know. I say, look, the middle point is 7, 2. One of the starting points, one of the endpoints is 1, negative 4. The other endpoint, I don't know. Now, I'm not worried that it's a straight line. I mean, technically it goes like this. We drew it before, but that's irrelevant. This method will work. So what we're focusing on now is the letter before the comma there, the letter before the comma there, and the letter before the comma there. So let's look at these two. We've got to look at them and say, what do you add or subtract to 1 to get it up to a 7? Well, I add 6 to it, because 1 plus 6 gives 7. This 1 plus 6 gives 7. So then I continue that arrow, and I'm going to plus 6 to the number again. 7 plus 6 is 13. So I now know the x value of my endpoint. Now we're going to focus on the number after the comma, the y values. What do you add or subtract to -4 to get to the number 2? Well, we just happen to add by 6 as well. These won't always be the same. Most times they'll be different. But -4 plus 6 gives 2. So I follow the arrow again and I add 6 again. 2 plus 6 gives 8. And there's your answer. B is the point 13, 8. We're finished. Either method's fine. You use whichever method you feel comfortable with. Time for you to try doing some questions. Enjoy the experience because it's maths and it's fun. Bye for now.